think that's what Alex prefers, but essentially these two things both mean empty set. Not an element is the little pitchfork thing. If A and B contain exactly the same elements, what are they called? Remember that? They're equal. Like I said, I'm not going to be able to go through all of them, so I'm just going to hit the highlights. The quit set is a subset of every set. The empty set is a subset of every set, remember? I can't make a decent empty set. All right, if two sets have the same number of elements, but those elements may differ, remember what that is? That's the equivalent thing. But they have the same number. Can two sets be equal, but not equivalent? No, they can be equivalent, but not equal, but not the other way around. If they're equal, then they're going to be equivalent. What is this right here called? If A is a set, then A complement is what? Well, I just said it. A prime is called complement. Like I said, I probably wouldn't start with this one if I were you. Like I said, I would use this one first. Over here, it's called the course review. It's the only thing. Well, you had a midterm one, and this one. There was the midterm review, and then there's the course review. They both are coded as homeworks. So this would be the one I would suggest doing first. Like I said, and then if you want to get more in depth, I would use the one that I'm going through. The only reason I'm not paying attention to this one is there's no way I can go through the whole course in one day today. So this right here, the set of all elements in common with two sets is the intersection. And remember that symbol? Some of these things, like I said, this is made by a committee. So some of these things are kind of weird. You got the answers in there, but I'm only going over the ones that I think are important. Two sets are said to be disjoints or mutually exclusive if A and B is equal to 0, the number of elements. 13. The number of elements is the and this is what they call it. It's got that funny name, cardinal number. All right, so how do you determine whether something is an element? Okay. Is 12 an element of that set right there? Even though it's not physically in there, it's going 1, 2, 3. So that's establishing the pattern. And then it tells you the last one. And from that pattern, 1, 2, 3, it's going along individually. So 12 will be in there. So this is a true statement. 7 is not an element of this set. Well, it's the same thing. It's starting off 1, 2, 3. So it's going to go 4, 5, 6, 7, 8, 9, 10, all the way up to 40. So this is false. Are these two things equivalent? Well, the way you find out if they're equivalent is you count the number of elements. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is yes. And inequality means that not only do they have the same number of elements, they got to have the exact same elements. The order is not important, so P is in there, Q is in there, R is in there, S and R, so this is equal. So this right here, as long as all these elements are over here, then we can say that it's a subset. And that's true because 6, 8, and 10 are in there. You could also say that it was a proper subset. Either one of those would be true. 14, 27, 32. Nope. Because 14 is not over here. Now this you got to watch on this 17. How many elements are there in this set over here on the left? How many elements is that? That's only one element in there, because elements are they're separated by a comma. So there's just one element in there. This one's got 3, so this is not a subset. Remember how to do the number of subsets? There's that formula. All right. And then 2 to the n minus 1 is number of proper subsets. Because you're going to take out that one that's equal. Oh, and Albert, I was just thinking, because I was putting together a question, I think it was what Ashia asked, that her learning path grades weren't over there. That may well be what the reason is your average is different. Because like I said, those don't come over until the due date. So how do we find this? We're going to use the second formula because it says proper subsets. 1, 2, 3, 4, 5, 6. And 2 to the 6 is 64. So there's 63 proper subsets. All right, you're doing okay? Another one down here. Oh, there it is. All right, so number 19 is just talking about a set. Pasta comes with tomato sauce and can be ordered with some, all, or none of these ingredients in the sauce. 1, 2, 3, 4, 5, 6, 7, 8. How many different variations are available for ordering pasta with tomato sauce? Well, it says all or none of these ingredients. So that's just a fancy way of saying 1, 2, 3, 4, 5, 6, 7, 8. N is equal to 8. So 2 to the 8th. So that's 64. 132. Let's see. That's 256. If A is equal to 9, I'm sorry, the number of elements in 9, how many proper subsets? Well, that's that same thing where we do 2 to the 9th and then take away 1. It's the same question as with 18. All right, what about the complement? If you've got the universal set and then you've got a particular set that you want to look at, then you can find the complement by taking out what's in the set. In other words, this is the way I kind of like to do it. Just taking out, and then what's left over is all right. So then Q and not Q should not contain any common elements. And when you put them back together, you get the universal set. So 1, 2, 4, 5, and then A, B, C, D, and E. Let's try this one, and then we'll try one more in here for set for chapter 2. All right, so what you got to do is, in order to do this, you got to find out what B complement is. what's not in B? So we got R, T, U, V, W, X, and that should be it. Is that the complement? Should be everything that's not in B. Q, R, S, T, U, V, W, X, Y, and Z. So that's it. Now we got to take A and B complement to find out what this is. And we're talking about the common elements. So what's common between these two? Looks like the only thing that are common are to find the complement intersection. We first need to find that intersection. So what's common between A and C? W, Y. All right, now we got to find out what's not in there. Well, it's everything except W and Y. All right. Any questions so far? I figure as long as we get through the first 3 chapters, we should be all right. I mean, so I know it's like I'm rushing things, but like I said, if we only got 40 hour and a half, so like 20 minutes on each chapter we're looking at. All right, so we've already, no, we didn't figure out. We got to figure out B intersection C first. So in other words, what do B and C have in common? Looks like it's just Y and Z. You see a mistake, Yelp. It says B and C. That's this side here. We got to get that first. That's in the parentheses. All right, now we got to union that with A. In other words, we got to take A and add it to that one, the one we just did. And it doesn't add anything. A union B complement. So find out what A union B is. So that means putting these two together. A union B. Q, S, U, W, Y, Z. That's an A union B. We're just kind of squashing them together so that we got both of the elements there. And then we got to take the complement. So what's not, it's R, C, and X. Because Y and Z are in there. And now we got to intersect that with C. In other words, take the common elements between this and C. And it looks like the only thing that's common is X. Let's see. Let's look at the next section. When these are written out, they're essentially doing the same thing, but you're doing with words. But like I said, I'm trying to hit highlights to just shake up your brain, because you're going to have to go through and be the one that practices on that review.
Can you go back up to the sets for 1 second? So I'm watching in the kitchen. I'm prepping for Thanksgiving. In the sets, the complement, down a little. I can't use the microphone on my tablet. Is V also in both?
You talking about for this one?
Yeah, A union with B complement.
Okay, all I can do is go back and see. So A union B is Q, F,
or is it what's not in both?
W, Y, and Z. So that's right. Now, what's not in this?
Not in both. Okay.
That's not here. So Q, S, U, W, Y, and Z can't be in there. So what's left over? Like I said, the quicker way to do it is, since we this is one time, take out these.
A, B, C, S, V, Y.
And then R, T, V, and X. So that's right.
Okay. I was comparing it to,
and intersecting that with C. So, oh, you know what? Intersecting with C. There's also a V there.
Yeah, that's what I thought. Okay.
Okay. So V and X.
Making sure I was doing it right. Okay.
Like I said, next Thursday is not class. I'm trying to see how I can do a review section, but I got 3 different classes. So if y'all are interested in something like that, you can let me know how to do it. I mean, I might just do it as like do one of the ways we would do it on the West Bank. We would do it on that Thursday, and then there would be different tables for different courses, but I could do all the courses and just kind of work with individuals. And that's the way I'm thinking about doing it. And I'd have to, I wouldn't be doing it in the normal sense that I'm doing it like this. But if that sounds interesting to you, let me know. because I don't mind doing it. I just not going to be able to do it the same way just because I got 3 different classes. And then I got to get ready for exams and all that. All right. So let's go on down. All right. So this is, we probably ought to do this one. I didn't do black. I wanted to do a different color. There we go. All right. So dog, cat, goat, or parrot, or whatever it is. Yeah, parrot. All right. So you got to find the best place to start. Usually with these in ALEKS, and this is an ALEKS problem. You gotta all right, so 15 had none, so 15 is going to go out there. Let's go. Okay, 18 had a cat and a parrot. So cat and a parrot. So this is going to add about 18, but we don't have enough information there yet. Okay, 8 had a dog, a cat, and a parrot, so that's what we want. All right. 18 had a cat and a parrot. So that means this is going to be 10 here to finish out the 18. Okay. Eight had a dog and a parrot. This is the dog. Looks like a P. 8 had a dog and a parrot. So it looks like there's going to be a 0 there because that's the same as all 3. So there's no more. There's no dog and parrot only. 18 had a dog and a cat. Hold on a second. Okay, that's the one I just got here. And 18 had a cat and a parrot. So that's I crossed out the wrong one first. But they're both 18. All right, now 21 has a dog. 23 has a dog. So we're going to take the 23. And what is that? That's 5, right? Anyone had a parrot. So again, it's 18. So that's 3, right? 18, 19, 20, 21. So there's 21 in there that had a parrot. And then 30 had a cat, so that's 28. So there's 2 more. 10 and 10 is 28 plus 2 is 30 that had a cat. Now, once you get that, the questions should just roll off pretty easily. You might want to check it and see if they all add up to 53, but I'm going to roll the dice here. How many had only a dog? Just right here is only a dog. How many had only a cat? How many had a dog and parrot? Dog and parrot, but not a cat. 0. Oh, that's not right. How many had a dog parrot. So this is dog and parrot. But then, yeah, that's right. So it's 0. This is dog and carrot. I'm sorry, dog and parrot, but no cat. All right, any questions about that one? Like I said, that's pretty much the highlights for chapter 2. All right, so again, I'm not going to go through every little thing on here because, like I said, I don't know what the intention was on this thing. It's got, like the review in the Alex has got 30 problems or 32 problems for the whole for the whole course. This one's got like 30 for each one of the chapters. So there's no way to be able to go through everything. So I'm going to go through the highlights. Remember, a statement has got to be either true or false. It's ambiguous, or if it's a question, so we can leave out that one. But it says simple statement, so this is not a simple statement, it's a compound statement. This is also a command, it's not a simple statement. This is true, this is true, and this is true. Now, the negation of a false statement is true. Remember, that's what all the negation does. So I'm not going to write it out, I'll just say it. The Pilgrims did not land in Tahiti, so the negation of that is the Pilgrims did land in Tahiti. Vitamin C helps the immune system. Vitamin C does not help the immune system. So it's basically, if it's a negation, to take the negation turns it into a true statement or a positive statement. And then if it starts out as true, then when you negate, it's going to put a negation in it. That's your 4 connectives. Or, and, if, then, if, and only if. And this would be compound. And that's what that statement was up here. See, that was a compound statement. Because it's got 2 simple statements showing with an and. We have another time I might come back to that one because remember there's that little thing where you got all has the negation of, got it in notes, I just don't have the notes open, but that's where that comes from. The little cross thing, and then it's all, and then some are not, and then all, what is it, none, some are, and then the negation of each other. Like I said, I'm trying to hit the highlights. This is the conjunction, and that's and. This is the disjunction, that's or. This is the conditional, and that's if, well, this is if, then, and the conditional is called, it's called conditional. This is the biconditional, and it's if and only if. See what else I got. Remember this. This is always true. Like for an argument, you have to have a tautology. It's a conditional statement. So if you got all falses, though, it's called a self-contradiction. Otherwise, it's false. The disjunction is true when either P or Q are true. The only time it's false is when both are false. It's false only when P is true and Q is false. Let's see. In other words, if you got two truths, the biconditional is true. If you got two falses, the biconditional is false. It's true. All right. You should know how to do a truth table, but I'm going to do a truth table. I'm only going to do one of them. I'm going to do the one for the argument, since that's mainly what the purpose is. So if it's a tautology, and you got all truth. And that's, again, when you've got an argument, as we'll see down there, if it's all truths, tautology, then it's a valid argument. So the converse is when we turn them around. Come back to that one. Let me just make sure. The inverse is what we got. Not P. And the contrapositive is both of them. Both of these put together. All right. So the way you'd handle a negation is you just use this. All right. So since these two things are equivalent, these are equivalent. Let me just double check something before I PQ. Oh, this one's backwards. That's why I wanted to check. So oh, wait a second. He's got this one backwards also. So this is true. Sneaky. But I was just going to show you this on which this is based so we can answer that one that's blank down there. If P, then Q is equivalent to not P or Q. So then what we can do to find the negation is you use the what is it, the De Morgan's laws. And remember De Morgan's laws, it changes the sign of these and flips that. So not P and not Q. So that's P and not Q. So this is premises and conclusion. And it's tautology. And this would be now there was two different ways you can tell whether these things are valid arguments or not. There's just standard ones, and you can go back and check them in the notes. I'll mention them in Alex. But this right here is the this is the fallacy. You know what? It's not the fallacy. I think we might as well just do the truth table on this one. I kind of wanted to do this one from scratch, but let's just do this one. All right, so this gets written as all right, and we've got only two statements, so this one should be able to put this up here somehow. I'll tell you what, let me make it smaller. Actually, I can put it in the darn text. Okay, so that's what we're going to do the truth table for. And the same thing be done here. You just have to also translate the statements into P and Q. Hopefully that's enough there. Now you remember, you always set up these two the same. That's pretty universal, setting them up like that. All right, so the first thing I gotta do is this one, and that's just the standard truth table for the conditional. That's the only one that's false. And then we need the not P, which is just the opposite of P. All right, so then we're gonna put these together with the and. So I'm just gonna put an and there to put these two together with. So we're using the and rule on these. False, false, true, true. Now we need to have, I need one more line. I have to squeeze it in there. So this is Q for not P. So we're looking at these two, and we're using the OR rule. All of them are true. The only one that's not true is the second one because both of them are false. Now this is the whole thing. And we're taking and using these two with the final rule here, the final conditional. The last in an argument, your conditional is always the last one you do. True, 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 true. So this is a valid argument. And this is, I mean, even though it's valid, I don't know of any standard one. So they put one on, they can put one on there. Oftentimes, usually the ones that they have are pretty standard in Alex. So, but you know, you sometimes may have to do a truth table to just tell. All right, let's see. One more chapter. We got 15 minutes, huh? All right, remember the fundamental counting principle? All right, you just take the number in each category and multiply them. So what would that end up being? You got 4 solids, 8 main courses, and 4 desserts. So how many possible? What is that? So 256 3-course meals. This is the same kind of thing. That's the fundamental counting principle. You got 2 letters and 4 numbers. I'll just talk you through it. Each letter has 26 possibles, and then you're multiplying 4 tens. So that's going to add a 6. So that's 26 times 26, and then you're adding 4 zeros. So that's 6,760,000. All right. So permutations and combinations. Permutations are when order is important. Combinations is when they're not. Now this right here is simply going to be 6 factorial. But what I want to do is set up the one of each of the combinations and permutations. A club consists, elects a president, vice president, secretary. So that's 3. How many sets of officers are possible if 9 to choose from? Now, does this thing have the calculator in it somewhere? Usually has it when you need it. So you can just pop that into the calculator. Let me remind you again where that's at. So that's this thing here. It was 8. So that's 336. Now, here's one. How many ways can a committee of 3 men and 4 women be formed from a group of 8 and 9? So there's no pretense of order. So for the men, it's 3 out of 8, and then 4, and you're going to multiply these. And so you can have the calculator again do that for you. 8394. So 7,056. Remember, this little thing here means conditional. All right, that's the thing that stands for conditional. Given, whenever you see the word given, That's how that reads. That's the probability of B given that A has happened. And this is just basically going back to what we talked about in the chapter 2. If two events are mutually exclusive, then the probability of both happening is 0 if they're mutually exclusive. And if they're independent, that has to do with two events. This is the probability of A or, I'm sorry, plus. So they want the general formula. And this covers both. If they're independent, then this just means the probability of B. And if they're both mutually exclusive, then this is 0. I'm sorry, I messed up. That's not equal, that's minus sign. All right, so we're running out of time here. Let's see what else I can get into real quick. All right, let's do this right here. This should probably take this over the last. Okay. A bag contains 3 red, 4 blue, and 6 red marbles. A ball is selected at random and the color is noted. All right. So the probability of selecting of red. All probability is just going to be the denominator is the total. So that's 10, 13. And then how many of them are red? 3/13. So that's 7 and 6, so 13. The probability of selecting a red given the ball sector was not blue. So, not blue, there's only going to be 9 of those. Personally, I don't think that's a really good question. I should have said, generally you would do that with something, each ball also has a number on it. And then you could say the probability of it. If they're not blue, given that they're not blue, what's the probability? That's an even number, something like that. All right, so you got any last questions? Stick around. Like I said, guys, if you want to try to get together on Tuesday, I'd be glad to do it. I'm just not going to be able to do. I'll either have to do something and it might be at a different time, or if you want to get together for this class, we'll just do a brief class on Tuesday. But that's technically the days that end the classes.